The factorial of a number is what we're writing when we write an exclamation point after the number. So 6 exclamation point really can be read as 6 factorial. And this is just math notation that means something very specific. So 6 factorial is actually equal to 6 times 5 times 4 times 3 times 2 times 1. So whenever you see a number and then factorial after it, it means multiply that number by all of the integers less than that number until you get down to 1. So this is 6 factorial, but 4 factorial would be 4 times 3 times 2 times 1. 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you get the idea. In this video, we're going to do a bunch of factorial problems. And the thing to remember is that when we're doing arithmetic with factorials, so we're adding factorials together, subtracting factorials from each other, or doing multiplication and division with factorials, we need to always remember to calculate the individual factorials first, and then do the arithmetic of the combination. So let's look at what that looks like. Here we've got a bunch of arithmetic problems with factorials: addition, subtraction, multiplication, division. And with all of them, we're going to need to calculate the individual factorials first. So 4 factorial plus 3 factorial is not 7 factorial. We just don't add the numbers together. We calculate the factorials individually. So 4 factorial is 4 times 3 times 2 times 1. And then 3 factorial is 3 times 2 times 1. So 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is 24. So we get 24 there. And then 3 times 2 is 6. 6 times 1 is 6. So we get 24 plus 6 is equal to 30. So 4 factorial plus 3 factorial is 30. But we calculated the individual factorials first before we did the addition. Here we'll calculate the individual factorials first before we do the subtraction. So 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. 3 times 2 is 6. 6 times 1 is 6. And then 2 times 1 is 2. So we get 6 minus 2, or 4. With multiplication, same thing. 3 factorial we know is 3 times 2 times 1. 2 factorial we know is 2 times 1. 3 times 2 is 6. 6 times 1 is 6. And then 2 times 1 is 2, so we get 6 times 2, or 12. And when we do division with factorials, again, we calculate the individual factorials first and then do the division. So 6 factorial expands out to 6 times 5 times 4 times 3 times 2 times 1. 4 factorial expands out to 4 times 3 times 2 times 1. Now here's the interesting thing about division. Because we have all multiplication in the numerator and all multiplication in the denominator, we know that 4 is a common factor to both the number in the numerator and the number in the denominator. 3 is also a common factor, and 2 and 1 are both common factors as well, which means that we can cancel those common factors before we do all this multiplication. It's like reducing the fraction to its lowest terms. So the 4s will cancel, the 3s will cancel, the 2s and the 1s will both cancel. And so then what we're left with is just the 6 times 5 in the numerator, which is 30. So whenever you're doing the division, first write out the factorials, expand them, then cancel common factors, then do your multiplication. That'll save you a lot of time when you're doing the multiplication through both the numerator and denominator. And then lastly, sometimes we're going to be asked to solve problems that are going to require us to use factorials, and this is a really common kind of problem. So this problem asks, how many different 5-person teams can be made from 10 people? So basically, imagine that we have 10 people standing around in a group, and we want to divide them into 5-person teams. In other words, we're going to have 2 teams of 5. And we want to know all of the different ways that we could arrange these 5 people. So for instance, if I assign each of the 10 people a letter, so person A, person B, person C, etc., and I have 10 people, I could make a team with A, B, C, D, and E, or I could make a team with A, B, C, D, and F, or I could make a team with A, B, C, D, and G. So there's all these different combinations. The good news is that we can actually use factorials to solve this problem really easily. So what we need to realize is that there are 5 spots that we want to fill. So if I have a team of 5, I'm trying to fill 5 spots, and the order of the people in those spots doesn't matter. In other words, a team with person A, B, C, D, and E on the team is the same as a team A, C, E, D, B. It's the same 5 people, but just in a different order. So those wouldn't count as 2 different teams, it would count as the same team. So if I have 5 spots I'm trying to fill, what I need to realize is that I can put 10 people in this first spot because I have person A through person K available to me. I can pick any one of those 10 and put them in the first spot. But after I've chosen one person to go into the first spot, I need to now choose a second person, but there are only 9 people remaining to choose. So that means I would have 9 people to choose for the second spot, 8 to choose for the third spot, 7 to choose for the fourth spot, and 6 to choose for the fifth spot. In order to solve this question, all I have to do is figure out this piece and then simply divide this by the number of spots I had available factorial. So because there were 5 spots, I divide by 5 factorial. So in the numerator, I multiply 10 times 9 times 8 times 7 times 6, and because there were 5 spots, I divide by 5 factorial. Now, if I write out 5 factorial, I say 5 times 4 times 3 times 2 times 1. And now I don't have any obvious common factors in the numerator and denominator, but what I do realize is that I can still simplify my multiplication. So for example, if I look at the factor of 10 and 5, 10 over 5 is the same as 2 over 1. That would cancel the 5, and the 10 would become a 2. I can do the same thing here. I can cancel the factor of 4, and because 8 is 4 times 2, I'm just left with 2 here. And then I can cancel the factor of 3, and 6 will just be reduced to 2. Now my multiplication is 2 times 9 times 2 times 7 times 2 divided by 2 times 1. I can again cancel a factor of 2 and 2. And now I just have 9 times 7 is 63, and 2 times 2 is 4. So I get 63 times 4 divided by 1, but dividing by 1 has no effect. So I just have to do 63 times 4, which I can say is equal to 252. So there are 252 different 5-person teams that I can make from 10 people.